Hello, this is Mr. Stansbury. I'm going to take you through the 14B notes on relative frequency. At the end of this, you should be able to say, I can find the long run probability of a given experiment. All right, so first thing, long run probability is an experiment is repeated several times and the experimental probability is found. So the more you repeat a experiment, the closer you are to finding what should happen mathematically every time. Okay, so we're going to actually do that with our graphing calculator here. I'm going to use a TI-84 and we're going to actually simulate a coin flipping activity. So we're going to hit apps and then we're going to scroll down until we get to, there should be a probability one down here in the P's. Let's see, probability simulator. So we're going to enter into that. It's going to give us that business. And what we want to do is we want to simulate tossing coins. So we're going to do that here. And we could go in and set up the data, but really it's just going to toss a coin one at a time. So first thing we'll do is just hit toss and toss a coin and we get heads. So after the first one we have one head, no tails for a 100% heads. Okay, now if we were to just do that, we would assume, if that was the only trial we did, that we ever did, then we would assume that every time we flipped a coin it would end up heads. But we know that that's not true. So what we got to do is do some long run probability on this. So we'll flip it again, and second time it also lands heads. So now we're 2, 0, still 100% on heads. And we're going to just keep flipping. Let's see, third one is heads, fourth one is tails, and the fifth one is tails. So we are 3, 0, 100, and then 3, 1. Let's see, that's going to be, what, 75%? And then we're 3, 2, which gives us 60%. So as you can see, we're moving towards what we know to be true. It should be close to 50%, right? So we're getting kind of closer there. The more trials we do, hopefully the closer we get. So let's get up to 10. So we'll just click this 5 more times. Riveting, I know, watching a computer coin flip. I think that was 5 times. 5 and 5. So magically we're at 5 and 5 for 50%. Okay, and then let's do some more. So this will flip 10 at a time for us, and then we just go over, use a little arrow, and it'll give us the frequency. So we're at 12 tails, which means 8 heads. So if we do, let's see, 8 divided by 20, we get 0.4 for 40%. All right, so let's do 30 more so we can get up to 50. See what happens. So now look, tails is really kind of taking over here. But again, hopefully the more long run, more trials we do, hopefully the closer we should get back to 50%, which we are not really super close there. 32, and the other one is at 18. That is not very close, but that's all right. So let's do 18 divided by 50. And we get 36%. Again, not terribly close, but we just kind of go with it. And now we can actually do a plus 50 to get up to 100. So it'll just kind of add them up until we get to where we need to be. So you can kind of see heads is trying to catch up here, but it just isn't. Let's see, we got 54. At least it's a little closer. So we're 54 and 46. So now we're back up to 46%. Okay, and then let's go up to 200. So let's do 50 a couple more times. And then we'll see what we end up at. All right, and I'm going to hit it one more time, and that'll take us up to 200. We're not going to get up to 10,000 because that's going to take an eternity to go through. But look, heads actually caught up and actually has passed up tails at this point. So it is now at 97 for tails, which means 103 3 for heads. So we do 103 divided by the total amount, which is 200, which gives us 51.5%. Okay. Okay, so while we are flipping these coins here, we're going to actually watch a little Board Shorts TV video on math. See if you ever felt like this.
10 minus 1. I don't know. 1, 2, 3, 4, 5, 6. 6, 7, 8, 9, 10. Nope. Take away 1. Which is it? 1, 2, 3, 4, 5, 6, 7. Nope. 1, 2, 3, 4, 5, 6, 7, 8. And one more. And add one more. How many does it equal? 1, 2, 3, 4, 5, 6, 7, 8. 1. It makes 9. See how you take away? You take away 1 and it equals 1. Do you get it now? Yes.
That never ceases to make me laugh. So anyway, thought I'd share. So this one here, after we flipped it, we're now up to 500. So we got 235 for tails, which means we are at 265 for heads. Let's see what the percent is there. So we take 265 divided by 500, and we get 53. So again, we're not getting exactly 50%, but we're getting pretty close to 50% on that. Okay, so that's this is kind of showing long run probability. Okay, we should be getting closer and closer to what we should expect mathematically to happen. Okay, so one last quick little thing to take a look at. Oops, that is not it. It's weird. I don't know why that's black. I don't know why it's not black, but that's weird. I guess we'll just go with it. All right. So what we're going to do is we're going to do the same thing, just really briefly, with 3 coins. So what you can do here is you can clear all the memory, sure, and then we're going to escape and we're going to go into set. And now we can actually go in and we can do 3 coins instead. All right, so clear table, sure. I don't know what the heck that means, but that's all right. So we'll push OK, and then we'll toss. So this will toss 3 coins all at the same time. So we get tails, heads, and tails. So what we're going to count is we're just going to count the number of heads. So in this one there was, oops, let's see, got to get a pen going on here. So we got, there we go, 1 head, none, and none. So we have 0%, 100%, and 0%. All right, try it again. And we get 3. Oh, oops. Let's see. 0 heads, 1 heads, 2 heads. I should have 3 on there, shouldn't I? Silly Mr. Stansbury. All right, let's just, I'm going to put a 3 in here, and we're going to kind of cut this table in half. Watch me try to draw a straight line. So that one was 0, so now we're at 1. All right, so none of the trials had 0 heads. One trial had 1 head. 2, sorry, yeah, one of them had 1 head. There was none that had 2 heads, and 1 had all 3 heads. So we're at, that would be 0 for this one. 25, no, not 25, but 50%. And then this would be 0, and then this would be 50%. Okay? So let's toss a couple more times. Let's just skip down to the 5. Okay. So we ended up with, on this one, we have 1. Oops, I lost track. We have 1 there. We have 2 here, 1 here. Oh, nuts. That's supposed to go over here. Sorry about that. 1, 2, 1, and 1. So again, this is, they're 20% each, so 20, and then this is 40. No, that's out of 5. Yeah, that should be right. 20 and 20. Okay, good. That adds up to 100. I was getting a little worried. Okay, let's try just a few more. Let's do 5 more to get up to 10. Again, I know, riveting to watch, isn't it? 3, 4. Come on, you can do it. And then 5. Okay, so we got 1, 5, 3, and 1. 1, 5, 3, and 1. So we should expect these numbers to start kind of equaling out. So let's just go straight to 10 more. I'm just going to go through, and it's not equaling it out at all. Actually, it shouldn't be. It shouldn't be all equal. But it should be this nice little bell curve. So let's try. Let's see, that's 20. Let's just go up to 50 and see what we get. All right, I'm going to pause it for a second here so you don't have to watch all this. All right, so here we are with this. We're at 3, 29, 12, and 6. All right, and again, I'm going to pause it, and we're going to do. Okay, so just to end us off, we're up to 200 here. So we're at 24 for that one. Let's see. 79, 68. And then the last one is 29 in there as well. Okay, so again, it should be this nice little kind of bell curve here on that. All right, so this is all long run probability. I'm going to take this off here so we can go back to our target. So you should be able to now say that I can find the long run probability of a given experiment. Though actually, let's take a quick look on this here because we didn't actually calculate the probability. So let's just do that really quick. Okay, so 24 divided by 200 is 12%. And then we have 79 divided by 200 is 39.5. And then we have 68 divided by 200 is 34. And then, oops, wrong one, 29 divided by 200 gives us 14.5. Okay, so that's the those are all the long run. Well, we're getting closer and closer to the long run probability on that. So a good little challenge for you is to figure out what this should be mathematically. What should it get to when you get up to 10,000? Don't actually go to 10,000, but go through and try to calculate what that is. All right, so again, now you should be able to say that you can find the long run probability of a given experiment. Oops, 14 minutes. Sorry about that. If you have any questions, feel free to ask. Thanks.